All right, let's dive right in. If you've been coding in Swift for any real amount of time, you've probably run into this. It's a question that really gets to the core of how Swift is designed, its whole philosophy. And that big question is, can structs actually inherit from other structs? I mean, it feels like they should be able to, right? Especially if you're coming from other languages where inheritance is just everywhere. So what gives? So the short answer? A big, fat no. They can't. And look, this isn't some mistake or a feature Apple just forgot to add. It is a 100% intentional design choice. And we're about to break down exactly why. Okay, to really get this, we gotta go back to basics. One of the most fundamental ideas in all of Swift, really. And that's the whole value versus reference type thing. Honestly, this distinction, it's everything. So, structs. They're what we call value types. What does that mean? It just means that every instance of a struct holds its own unique copy of its data. So whenever you pass a struct around in your code, you're not passing the original. You're handing over a brand new, totally independent copy. Think of it like this. Every time you assign a struct to a new variable, it's like making a photocopy of a document. If you take that new copy and scribble all over it, draw a mustache, whatever, the original document is still perfectly clean, totally untouched. And that's the magic, right? It's what makes them so predictable and safe. No weird side effects. Now, inheritance, that's the world of reference types. And in Swift, that means classes. So if a struct is a photocopy, a class is like a shared link to a Google Doc. You send that link to 10 people, all 10 of them are looking at and typing on the exact same document. One person deletes a paragraph, it's gone for everybody, instantly. You can see why trying to smoosh these two ideas together would be a total mess, right? How can you have an independent, separate photocopy that also magically updates when the original changes? It just doesn't make sense. It breaks the whole point of a value type. So Swift makes a choice. Keep them separate for the sake of safety and predictability. All right, so if inheritance is off the table for structs, how in the world are we supposed to share code and functionality between them? Well, this is where Swift gives us a really powerful, and I'd say pretty elegant solution: protocols. This is the heart of what people call protocol-oriented programming, and it's really a shift in how you think. Instead of the classic inheritance model where you say a car is a vehicle, you switch to saying a car can do what a drivable thing can do. See the difference? It's about capability, not who your parent is. Let's walk through how this actually works. It's pretty straightforward. First, you define a protocol. Think of it as a contract or a blueprint. We'll call it drivable. This contract just says, hey, if you're going to be drivable, you have to have this functionality. Then, the cool part, you can use an extension to provide a default implementation right on the protocol itself. After that, all you have to do is say your car struct and your bike struct conform to drivable. And boom, just like that, they both get that shared functionality. No inheritance needed. And the upside to this approach? It's huge. You completely avoid those messy, super deep inheritance chains that can be a nightmare to debug. You also don't have to worry about weird bugs from shared data because, hey, we're still using value types, those nice, safe photocopies. What you end up with is code that's way cleaner, way safer, and a lot more flexible. Okay, so let's put these two head to head. This little showdown should make the difference between a struct and a class crystal clear. Now, what's really interesting about this slide is how it lays everything out. In one corner, you've got classes. They're reference types, they've got inheritance, and their behavior is shared. Remember the Google Doc? They're your go-to for complex things that need a single identity in your app. And in the other corner, you have structs. They're value types, no inheritance, and everything is a copy, the photocopy. Absolutely perfect for simpler data models that you want to keep safe and independent. All right, we've covered a lot. So what's the big takeaway? If you only remember one thing from all this, what should it be? Let's boil it all down. Here it is. The fact that structs can't inherit isn't a bug, and it's not a missing piece of the language. It is the feature. It's a conscious decision made to protect the safety, the performance, and the beautiful simplicity you get from value types. And that's why the language, well, it really promotes protocol conformance as the primary way to share behavior. It's a different mindset for sure, but once you get it, you start writing code that's just better, safer, and way more robust. So I'll leave you with this to think about. Now that you really see the why behind this value versus reference stuff, how is that going to change the way you code your next feature? When are you going to reach for a struct, and when is a class the right tool for the job? Because making that choice thoughtfully, well, that can make all the difference.